All right, hello everyone. We're going to be doing section 2.2. So this is going to be the multiplication property of equality. So we just went over the addition property of equality, and now we're doing the multiplication property of equality. So really what we're going to be doing is the same thing as we did in the last section, except now we have a multiplication property instead of addition. So our objectives, we have two of them. One is that we want to use the multiplication property of equality, and number two, we want to simplify and then use the multiplication property of equality. So objective one, using the multiplication property of equality, the addition property of equality is not always enough to solve some equations. So sometimes we'll have something that looks like 3x is equal to 15. So given 3x is equal to 15, the coefficient of x is 3 and not 1 as desired. The multiplication property of equality is needed to change 3x equal to 15 to an equation of the form x is equal to a number. So the multiplication property of equality states that if a, b, and c represent real numbers where c is not equal to 0, then the equations a equals b and ac is equal to bc are equivalent. So in words, each side of an equation may be multiplied by the same non-zero number without changing the solution set. So this tells us if we have 3x equals to 15, we need to change 3x to x, or 1x. So we need to multiply each side by the multiplicative inverse of 3. Multiplicative inverse, remember, being our reciprocal. So if we have 3x is equal to 15, we want to multiply by our reciprocal of 3, which, since 3 is technically 3 over 1, our reciprocal of 3 is 1/3. So we're going to multiply each side by 1/3. This is going to leave us with 1/3 times 3 times x. Sorry about that. Is equal to 15 divided by 3, since we multiplied 15 and 1/3. This is using our associative property. So when we multiply by our multiplicative inverse, so when we multiply 1/3 and 3, we end up getting 1 times x, which is equal to 5. 15 divided by 3. Then 1x, we can say, is that's using our identity property, so we get that x is just equal to 5. When we want to check, we plug into our original equation, we get 3 times 5 is equal to 15, and 3 times 5 is 15. So we have 15 is equal to 15, and x equals 5 is our solution. So similarly with subtraction to addition, since we can define division as multiplication with the multiplicative inverse, we can extend our property to division as well. So the multiplication property of equality extended to division, we can divide each side of an equation by the same non-zero number without changing the solution. Do not, however, divide each side by a variable because the variable might be equal to 0. So we don't want to divide by a variable. We only want to divide by constants, coefficients. So with example 1, we want to solve our equation, and we have x divided by 4 is equal to 3. We can go ahead and rewrite this equation. X divided by 4 is the same thing as saying 1 divided by 4 times x is equal to 3. And so since we have our coefficient in front of x, remember now we want to isolate x, so we need to multiply each side by the multiplicative inverse of 1/4. The multiplicative inverse of 1/4, or our reciprocal of 1/4, is just 4 over 1, or 4. So we multiply each side by 4. And this gives us 4 times 1 over 4 times x is equal to 3 times 4. 4 times 1 over 4 is just 1 times x is equal to 3 times 4, which is 12. And this is our identity property, and we get that x is equal to 12. And this is our solution, but of course we want to check. So plugging 12 in for x, we get 12 divided by 4 equal to 3. And we divide 12 by 4, and this gives us that 3 is equal to 3. Since this is correct, x equals 12 is our solution. So this is extremely similar to our addition property of equality in the sense that we just need to be isolating x, but in this case we're dealing with our coefficients in front of x instead of adding numbers to x. So objective 2, we want to simplify and then use the multiplication property of equality. So example 2, we want to solve the equation here, and we have 2 times x minus 1 minus 4 times x minus 2 is equal to negative 12. We have a much more difficult equation here. We see we want to use our distributive property. It looks like twice. We have things in our parentheses. So we want to be simplifying this equation before we can go ahead and actually use our multiplication property. So let's go ahead and use our distributive property on our first two terms. So 2 times x minus 1 is going to become 2 times x minus 2 times 1. And then using our distributive property on 4 times x minus 2, we're going to get minus 4 times x minus 4 times negative 2. This is still all equal to negative 12. So we want to simplify here. So 2 times x is going to be 2x minus 2 times 1, which is 2, minus 4 times x, which is 4x, minus 4 times negative 2. So it's going to be a minus negative 8, which is equal to negative 12. Since we know that minus a negative number or having a double negative is like having positives, so we can rewrite this to say plus 8 equal to negative 12 instead. And now what we want to do is we want to combine our like terms. So we want to rearrange our expression here on the left. So on the left-hand side of our equation, we have our expression. So let's change our subtractions to additions. So we can say 2x plus negative 2 plus negative 4x plus 8 is equal to negative 12. And now we can rearrange. Since we want to have our variable first, let's combine our variables and then we'll combine our constants. So starting with 2x, we're going to say 2x plus negative 4x. And then we have our plus negative 2 plus 8 is equal to what? Negative 12. I dropped the negative on the last part. So now we can combine our like terms. Our like terms are 2x and negative 4x. And then we have our like terms of negative 2 and 8. So 2x plus negative 4x is going to give us negative 2x. Then we have plus negative 2 plus 8. And negative 2 plus 8 is going to be positive 6. This is all equal to negative 12. So now we have x with a coefficient plus 6 is equal to some number. We want to use our addition property of equality in order to get rid of our 6 here on the left-hand side. So let's use our addition property of equality and subtract 6 from both sides. This gives us negative 2x plus 6 minus 6 is equal to negative 12 minus 6. So on our left-hand side, we end up with a negative 2x plus 0 is equal to negative 12 minus 6. Negative 12 minus 6 is like saying negative 12 plus negative 6, and this is going to be negative 18. Our identity property allows us to rewrite negative 2x plus 0 as just negative 2x, which is equal to negative 18. So now we have negative 2x is equal to negative 18. We have two options here. We can either multiply each side by the reciprocal of 2, or we can just divide by 2 on both sides. So when we divide by 2 on both sides, or what we can actually do is divide by negative 2, so then we can get rid of the negative on our left-hand side. And if we divide by negative 2, this is really giving us negative 2 divided by negative 2 times x is equal to negative 18 divided by negative 2. Since we have a number divided by itself, this is our property of 1. So this becomes 1 times x is equal to negative 18 divided by negative 2. Since they're both negative, our result will be positive, and we know that 18 divided by 2 is 9. So we end up getting a positive 9. And then we have our 1 times x, which is just our identity property for multiplication. So we get our solution of x is equal to 9. But of course, we want to check if this is correct. So let's check. Quite a few steps here. So we had x is equal to 9. We want to check if this is correct. So we have 2 times 9 minus 1 minus 4 times 9 minus 2 is equal to negative 12. So we plugged in that 9 for x. Now we're going to see if we get the same thing on each side of the equality symbol. So solving what's in our parentheses first, we get 2 times 9 minus 1, which is 8, minus 4 times 9 minus 2, which is 7, is equal to negative 12. Then we want to do our multiplications. So 2 times 8 is 16, minus 4 times 7, which is 28, is equal to negative 12. 16 minus 28 is going to be negative 12. So we end up getting negative 12 is equal to negative 12, which is a true statement. And this tells us that x equals 9 is our solution. So all right, that wraps up section 2.2 for everyone. And I will see you all again in section 2.3.